Hello guys, in this video I will explain the solution for the given problem, that is convert the decimal number 4312 binary in two ways. The first method is convert directly to binary. The second method is convert first to hexadecimal and then from hexadecimal to binary, and then check which method is faster. To solve this problem, let us take the given number, that is 431 with base 10. As it is a decimal number, the radix or base value for the decimal number system is 10. Now come to the first method, that is directly to binary. To convert any decimal number into binary number system, we should divide the given decimal number with 2, as the radix or base of a binary is 2. Now we should start the process of division and continue until the quotient is 0. 2 2s are 4, 2 1s are 2, 2 5s are 10, the remainder is 1. Again divided with 2, 2 1s are 2, 0, 2 7s are 14, the remainder is 1. Again with 2, 2 5s are 10, 2 3s are 6, remainder is 1. Again 2 2s are 4, 2 6s are 12, the remainder is 1. Again 2 1s are 2, 2 3s are 6, the remainder is 0. Again divided with 2, 2 6s are 12, the remainder is 1. Again divided with 2, it becomes 2 3s are 6, the remainder is 0. Again divided with 2, then it becomes 2 1s are 2, the remainder is 1. Again divided with 2, now it becomes 0, the remainder is 1. Now stop the process because the quotient is 0 here. Write the equivalent binary value for the given decimal number by taking the remainders from bottom to top. Then it becomes 1 1 0 1 0 1 1 1 1 with base 2. Now coming to the second part of the question. In the second part, first we should convert the given decimal into hexadecimal. To convert a decimal into hexadecimal, let us divide the given number with 16. Now 16 is the radix or base of a hexadecimal number. Now 16 divides 431 in 26 times, then the remainder is 15. 15 equivalent hexadecimal digit is F. Again divided with 16, then it gives 16 ones are 16, the remainder is 10, its equivalent hexadecimal digit is A. Again divided with 16, then its quotient value is 0, the remainder is 1. Now we should write the equivalent hexadecimal for the given number as 431 with the base 10 equal to, now take the values from bottom to top. 1AF with the base 16. This is the equivalent hexadecimal value for the given number. Now coming to the next conversion, that is hexadecimal to binary. To perform this conversion, first we should rewrite the obtained hexadecimal number, that is 1AF with the base 16. To convert this hexadecimal into binary, we should write the 16 in terms of power of 2. Then it becomes 2 power 4, where 4 represents the number of bits required to write each digit in binary form. Using 4 binary weights, those are 2 power 0, 2 power 1, 2 power 2, and 2 power 3. These equivalent values are 8, 4, 2, 1. With these 4 binary weights, we should write the equivalent binary for these hexadecimal digits. Then the resultant binary value for this hexadecimal is 0001. For A means 10, 10 means 1010, F means 15, 1111. This is the binary. Now coming to the third part, that is which method is faster. When we compare the first method with the second method has less computations than the first method. That's why the second method is faster than the first method. This is the complete solution for the given problem. Thank you.